Hi YouTube and hi Project B. It's Sean, your project leader here, and today I've just got some information for you before you hand in your memo. So to start off, I'm going to talk about the SOLVEM part, which is what people have been asking so far. So in Project B, the brief has already given you the sketch entirely, so there's little to no point in you regurgitating that drawing onto your final memo. Therefore, what we require you to do is we want you to do a process flow diagram of the system. Now this is very similar to the diagram that you drew in Eng 1100, and if you're not sure how to do this, ask one of your team members who have done Eng 1100 Project B, as there should be someone in your group that has done it before. If the worst case scenario arises, have a look on Google. There are plenty of explanations on Google that shows you how to do a process flow diagram, or you can approach myself or one of the tutors and we can assist you in that matter. So for that process flow diagram, what we're looking for is we're looking for you to identify all the mass flows, your energy flows, and also your data flows, using dotted lines for your data flows. Don't forget to label all your streams, and also name the streams if you can, as well as write in any technical information you might know about those streams, such as temperatures or flow rates that you've been given. You can do this either by hand, nicely drawn of course so we can mark it, as a block diagram, or if you remember how to use Microsoft Visio from Project B last year, feel free to use that program so you can use the correct symbols. Either way is perfectly acceptable. The next part is the OLV part of SOLVEM. Now I haven't heard too many issues about this part, but essentially all you're doing is you're writing down the observations that you see. You're going to be listing out your variables and constants, so writing the values that you know, what they are, and don't forget to use the correct units. The E part. Now the E part is the equation part. So what we're looking for there is you to look at all the equations that might come up throughout the course of the project. To give you a hint here, have to think about your mass flows in the system, your energy flows in the system. You'll also want to think about fluids. There might be some equations there. And also that tensile load system down the bottom. There's also some equations to do with that one. Perhaps you also might have some pump equations that might come in handy later on. Now in this part, it's really important to state your assumptions which you might be using, especially for the equations, and why you're using a certain equation or why you might not be using a certain equation. Assumptions are crucial and they're all throughout engineering, so make sure you clearly state them. The last part is the M, so that's the manipulation. What we're looking for you to do there is we want you to rearrange your equations so you can isolate the variable that you're interested in, and everything else should be on the other side of the equation. So for example, if you're talking about heat loss might be given to you in an equation with Q on one side. Now Q is an energy amount, but that's not what you're really interested in, because you might be more interested in how much temperature is changed, the temperature change. So you might want to rearrange for a temperature change in that equation. Remember, in this part, in the SOLVEM, you're not required to solve for a single number. You're only required to plug in the numbers that you do know and rearrange the equations as much as you can. There is no single final answer so far. So that's it for SOLVEM. I'm going to move on to some of the resources that are available. So the first thing is I've already updated the project brief. I've clarified a lot of the information on there based on student feedback because you found some of the information a bit ambiguous, a bit unclear. So I've given you some more information to do with that. So have a look at that project brief. It's been emailed out to every student and also updated throughout Blackboard. So please work off that one. In the technical resources folder under Project B, you'll also find the pump specs document, which has links to the 4 different types of pumps you will encounter. Now have a look at those pumps and you can learn a bit about them during your research in your memo. There's also a larger version of the tensile load system drawing in that folder as well. It's the same one that's in your project brief, just enlarged so you can see the numbers and dimensions on it. There's also a drawing of the rough dimensions of the project rig you'll be working with, so you know the scale of it. You don't need exact numbers again, and we're going to ask you to make some assumptions about what sort of piping structure, what sort of design you're going to use in there, because that's your design after all. Just keep in mind that the torque on that picture is referring to that tensile system at the end, and the 4 pumps will be attached to the middle of the table somewhere. So you're going to have to think about what sort of piping structure is going to go from the tanks to the pumps and from the pumps to that tensile system at the end. Keep in mind you also have to put your temperature sensor in there. And finally, I just want to talk about what's happening overall, the big picture of the project in the upcoming weeks to clear things up. So As you're doing the memo, the idea is you want to look at what sort of pumps you might encounter, and you want to choose a pump perhaps that you might want to go ahead with using. And if you look back to Eng 1100, perhaps you might want to use the decision-making matrix that you learned back there. From week 7, the problem-solving sessions stop, and you will split into 2 streams. You'll have either 2 or 3 students in each stream, depending on how many team members you have. There's the Simulink. It's a program, which is the MATLAB component. And there's also the CAD stream, which will be using a program called Creo. So, the Simulink component, the MATLAB side, what you'll be doing is you'll be modeling the entire system, including all 4 pumps in Simulink. Then you'll use those results to justify why you want to use a specific pump and what sort of results you expect to get. Then taking that single pump, you'll then use Simulink to write a control algorithm that incorporates all your various inputs from your sensors and other measurements that controls your cold stream pump. And that control algorithm will be converted to MATLAB code and implemented into our control that we've already built on the rig and used to control your system on demo day. For the Creo people, what you'll be doing is you'll be modeling the load arm. And now, your goal there is to try and minimize the weight of that load arm while preventing it from snapping. So you'll be doing some simulations on the stresses that the load arm might encounter when there's 10 litres of water mounted on it, and you're looking at how you can reduce that weight further and further. You'll create that design, give it to us, and we will cut it out on the university's CNC machines and give that piece back to you when it's done. You'll also be doing the tensile member. You'll be designing and building that yourself. So in weeks 7 to 9, you'll have access to the STC. You'll be given a choice of 3 materials as stated on the project brief, and you'll have the hand tools to cut and shape that tensile member to the correct specifications that you want. The last thing is, a portion of your team should, at that point in time, be working on your piping and building that piping component, the piping system. As part of that, you'll be mounting a temperature sensor into the pipes, so you'll have to think about how to submerge it, how to keep it waterproof, and finally, that temperature sensor is actually purchased from us. So we bulk bought all the sensors this year, so to make sure no student team is disadvantaged by getting a dodgy sensor. Everyone will have a working sensor that's the same, and we'll work on demo day. You'll need to buy that sensor from us when it arrives. We will tell you. Like I said on the brief, it's roughly $20, so it's about $4 per team member, and we'll let you know more about that when we do receive it. So until then, wish you all the best and happy engine.